In the previous lesson, we were introduced to Pascal's triangle, and now we're going to switch to something related to it, a topic called combinatorics. And the way this works, it starts with I have a question here. I'm in this grid, and I'm located I'm located inside this box, A1. I'm not on the corner. And I can travel to this box, but the rules is that I can only move either right or down. So for instance, that's one way of getting there, or maybe I go like that. And first question is, how many ways are there to do that? Well, there's two ways you can see, but then there's another one, here's one, here's one. So how many ways are there? How do you not count the same one twice? And how do you not leave one out? And another question is, if I take the numbers 11222, 11,222, for instance, that's a number that has two ones and three twos, but another number that has two ones and three twos is 12221 or 12122, and there's a whole bunch of different ways to do that. Push pause and see if you can figure out how many ways there are for each of these questions, and then we'll be back in a second. So maybe you got 10, which are the answers. It's hard to describe these paths. So one way of describing the path is to explain the steps you took. So this gray one that I just did, I went right, then down, then right, down, down. And to go maybe on this path, I went down, right, down. Notice how these two things have in common, they both have two R's and three D's mixed around. Well, same thing happens with the numbers 1, 1, 2, 2, 2. And here's a nice way I could list out all 10 of them. I can start with the two ones together, and I could leave the first one in the first place and kind of move over the other one. Till that one's at the end. Then kind of start again, but this time start with a 2 and put the two ones together. Then keep that 1 in the second place and move the 1 in the third place over and over again. Then start again with the first one in the third place and move over that second one, and then start again. And we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways. This one's a little harder to see what the 10 ways are, but I'm going to do something kind of sneaky here. I'm going to notice that these two questions have the same answer because each of them is creating the sequence of 5 things, in this case 5 numbers, in this one 5 movements, where there's 2 of one type and 3 of the other type. 2 ones and 3 twos, or 2 R's and 3 T's. So if I just take each of these 1, 1, 2, 2, 2 numbers and replace the ones with R's, I get a path that's going to get me from S to F. And if I do that for all of them, here I'm moving that second R over. Start with the D and then 2 R's. Move that second R over. Start with 2 D's, 2 R's, and finally get the 2 R's. So, 2 things. These questions have the same answer, and that answer happens to be 10. Knowing that they have the same answer is one thing. Being able to figure out the answer is another. Here's a more complicated situation. Well, this has like a lot. If you try the same thing, like if I go, it's really hard to list these out because there's so many. So there's a little trick I'm going to show you, and it's going to be a trick for answering number 3. But since number 3 and 4 have the same number of answers, it's going to answer number 4 also. And here's how it looks. I'm going to put a 1 here to say that there's only one way to get from S from this A1 spot to the B1 spot, just by going to the right. Say, likewise, there's only one way to get to the A2 spot from S, because I have to go down. But there are 2 ways to get to this spot, because I can get there from above or from the left. And I'm going to put a 1 here and all through here, because there is only one way to get to each of those spots. Like this E1 spot I have to get to by going all the way to the right. Right. But here's where it gets kind of interesting. For the C2 spot, I could either get there by coming from above, from C1, or from the left, from B2. So I add 2 plus 1 to get 3. I add the thing above and the thing to the left. And if I do that for this entire row, this happens. Now for the third row, to get to B3, I either get there from above. There's only 2 ways to get there, from B2 or from A1. So if I add those together, that's the total number of ways of getting to B3. And if I keep adding the number above and the number on the left for each cell, and the same thing happens over here. Add the number above and the number on the left, number above, and finally 35. Which means the answer to this question is also 35, although listing out the 35 might be kind of hard. They're not asking you to list them out, they're just asking how many. And you could even do it for a giant thing like this. And, well, I'm not going to go through it all, but when you do it, you will get the answer to this question and also this one. You can pause and go ahead and do it, and then when you unpause, I'll put up what the final answer is going to be. Go ahead and pause. Welcome back. If you do this properly, you should get 3003, which is quite a large number. That would also be the number of ways. Any path has 1, 2, 3, 4, 5, 6, 7, 8 R's, and 1, 2, 3, 4, 5, and 6 D's. So this would also be the number of ways of rearranging. What was I calling it? I was calling the ones were like the R's. So 8 ones. And 6 twos. That's a 14-digit number. Well, there's 3,003 of them that will do that. Now, what does this have to do with yesterday's lesson? Well, if you turn this thing, remember yesterday did Pascal's triangle. And you can see the 1, 1 is kind of like that. And the 1, 2, 1 is like, so we see a sort of Pascal's triangle here. 1, 3, 3, 1 is that. And we don't have the entire 1, 1, 1, 4, 6, 4, 1, but we have at least that piece of it. So somehow, the answer to this combinatorics question boils down to a Pascal's triangle question. So we're going to want to know eventually, is there some shortcut for jumping straight here, which is also a way of saying, is there some shortcut for jumping straight to some element of Pascal's triangle? And that's all coming. So that's today's lesson. It's about the relationship, how the numbers in Pascal's triangle are related to these combinatorics, how many ways of doing this or that.